once again, we're underneath a Travato doing a change of an isolation solenoid in the battery box. In this case, instead of replacing a dead solenoid, we're replacing a potentially still working solenoid, but with a Li-BIM device. This is an Li-BIM 225. This replaces an isolation solenoid, and it is your chassis battery, your house battery, ground in the middle. Over here is the IGN signal. That's going to be your LR wire from your boost switch. That is engine run signal, 12 volts when the engine's running. That would close the solenoid, the original solenoid. Ground, of course, is needed to complete the circuit between the signal wire LR and the ground in order to make enough power to operate the solenoid. In this case, this is just a signal input that tells it that it's allowed to close the solenoid, close periodically while the engine's running. This is the lithium version of a BIM as opposed to a standard BIM. Standard BIM does not cycle on and off. This one does. Otherwise, they're about the same thing. Also, the Li-BIM understands that lithium charge voltages are different from AGM charge voltages, and it doesn't accidentally drain the lithium batteries at a higher voltage thinking that they're being charged. The last terminal here is the SIG input. The SIG input is you either connect it to 12 volts or ground in order to tell this guy, hey, close now, I need to start the engine. If your chassis battery is dead, it'll do that. This thing will also charge the chassis battery on its own normally. So that's what we're putting in. And the tools you're going to need, of course, first thing being a drill driver of some sort, Phillips number 2. We're also going to use a Phillips 3 later. And a 1/2-inch wrench. Got my 1/2-inch wrench. This is taped for safety. And also a 3/8. Here we go. A 3/8 for operating the terminals. The smaller terminal posts, the 1/2-inch for the big terminals, the 3/8 for the small terminals, and also a 5/16 and some self-tapper bits for mounting it, but we'll get into that later. All right, first thing, to get the battery box open, not the battery box, sorry, the black box, which has the battery cable connections come together between the chassis and the house, and also the coach battery switch is in here, the actual relay that operates it. There's 2 screws on the bottom corners, and then screws slightly up as well. These all 4 have to come off in order to open up the battery box. And I get this one over here that you can't see. And then last one. And then the box should come off. Just like that. There will sometimes be dirt and stuff in the box. We even had acorns, courtesy of some squirrel. All right, you're going to notice here that unlike in the earlier model Travatos that have the silver tin can type of solenoid, this one instead has a plastic cased solenoid. This is what Winnebago has been using more recently. There's not really a whole lot of difference in this. They did, however, make another wiring change, which is that on the older model rigs with the silver tin can type of solenoid, this LR wire actually says LR right there, D-LR04. LR is the critical part of that tells us what this wire is by the Winnebago wiring codes. This wire on the older models had a second path coming out of here through a diode and then to a white wire to ground. And that's to take the negative impulse when this thing releases and shunt it to ground through the diode so that it doesn't get into any of the circuitry. They realized, I guess, that they didn't need that anymore for whatever reason, so they don't include it starting with 22. I believe this is a 23 chassis. Instead, we have somewhere in here. Here it is. I have a pre-made up diode on a couple of terminals, which we'll be installing along with the Li-BIM. The diode's necessary in order to get the boost switch to continue to function. I'll go over the boost switch wiring change at the very end. I'm going to take this bit out of the way. This is a thermistor that has to do with operating the coach battery switch. So this is the coach battery switch here. This green wire, I keep my hands out of the white light. This green wire is going to the power of the starter on the generator. So this green is generator. The generator itself is green, and the wire is green. That's kind of handy to know. This wire here, going up to this 50 amp fuse, is power, switched power, going up to the fuse box inside. So your 12 volt fuse box with your row of fuses that with LEDs that light up on the 16s and laters, but not 14, 15. That's powered through this 50 amp self-reset fuse, self-resetting breaker. It's thermal. If it gets too much power across it, it will open up, and that's just to protect the wires. It'll also automatically self-close again. So if you have a brief short ground, this will save the wire without the inconvenience of having to come down here and replace a fuse. This is the coach battery switch itself. When you throw the coach battery switch on or off, you may hear a little bit of a clunk sound. That's happening inside this box, and what's happening is it's throwing a metal bar open or closed across these two contacts. Now you'll notice that I'm touching ground and 12 volt wires here. This is 12 volt battery right here. This is house battery between these two. And it's not bothering me because skin resistance at 12 volts only, not 120 volts, mind you, but at only 12 volts, skin resistance is enough that you're not going to feel the power going through ground. I wouldn't want to do that if my hands were wet or I had an open sore. But relatively dry hands, not standing in a puddle of water, blah, blah, blah. It's normally safe to touch 12 volts as a human. So just to continue going across here, the yellow tipped red cable, this is a red cable with a yellow heat shrink end on it. This is the 12 volts from the batteries that are being changed to lithium, which is where we're going with the Li-BIM. This yellow wire brings the 12 volts in from the coach batteries. It touches this point. This jumper also brings it over to the relay. In these installs, I sometimes move this over to this post for convenience. I've only got two terminals on the Li-BIM. We'll see if that's going to be possible, or if it may be just as easy to go ahead and run them both off of the BIM. And in this particular configuration on 22s and later, sometimes it is either easier to go ahead and leave the yellow on the BIM because it does come in from this side instead of the other side. All right, let's get to disconnecting the wires. That's going to be the first step. Again, I didn't finish going over these wires. This red cable here, the red tip red cable, is the chassis battery. So this is chassis battery, this is house battery. When this solenoid closes, the chassis can charge the house, which should happen with an isolation solenoid anytime the engine's running. If the engine's running, that should be closed, which is why these two voltages, house and chassis battery, should be more or less the same. That's how you can tell if this thing has failed, is if the engine's running and they're not the same, or not within half a volt of each other. Clearly this is not closed, or it's closed but it's not making good electrical contact, which is how these fail. They build up too much carbon on the contacts. All right, let's get to taking these things off. So I'm going to take the chassis battery off just because it's easier to do. Helps if I get this into move, loosen, and there we go. I already got it loose. Take the nut off. There go. And I'm going to take this, and here is the tricky part. You want to make sure that while you're doing the work, that this cable is stable. When you let go of this, you don't want it to spring over and touch something ground. I'm putting this nut back on here just because I don't want loose bits floating around. All right, now we're going to do the other side. Sometimes need a little bit of extra room to get on that. No, gotta keep going. That should be enough. There we go. All right. Come off. It's hitting the heat shrink. Okay, so that's off. So now this one again, this is 12 volts positive. I could take the time to disconnect the grounds on the batteries on both ends, and as long as I am comfortable with these things not touching anything, then I'm going to go ahead and proceed this way. This is potentially still live because this wire here, let's see, which wire is this? Yeah, this wire here is for the ZAMP positive. So this black wire is the ZAMP charging the battery through this terminal. This other wire, which I have to admit, it should not be green. Green is a ground wire, not a positive wire, but in this case, you're using a green as a positive wire. Fortunately, it's one of the very few times that Winnebago makes this mistake. That goes up to this middle fuse. This middle fuse is a small little, I think it's only 5 amps, and that touches this smaller yellow wiring that is the power for this thing to operate. If you turn off the power, of course, how do you get the power to turn it back on? The answer is it comes through this fuse, separate from this one that feeds all the rest of the power. This fuse, again, is the ZAMP. I keep calling it a fuse. These are actually these little boxes with the 2 terminals coming up like that. Those are self-resetting breakers. They're thermal breakers. They'll pop open when they get too hot, but instead of burning out when they get too hot, they simply open up the switch, and then when they cool off after a little while, they'll close again and they'll start working again. So that just saves you replacing a fuse if you've temporarily had a problem. All right, so now we have everything except the ground and the LR wire off of and what we're going to need to do next, let me put this on here, is we're going to break out a PH3 bit. And a PH3 bit, because these bolts that are holding in the side of this, they are a larger Phillips version. They are not your typical, the most common PH2. So I'm going to put a PH3, which is a larger, come on, get there. I don't usually have trouble with this one, so it's giving me trouble. There it goes. So you can see here how this one is very much bigger than this one. It's got a smaller tip. If you use this in the larger bolt, this will grind out the surfaces. It'll slip and act like a drill bit and make it so you can't get it out at all. So you want to use the right size tool to mate up with this. Now I got to be careful not to let things short here on me. So I'm going to put that in there, and I'm going to crank up the power and go into slow mode. This thing has lots of torque. Should be able to break it loose as long as I don't. There we go. That came right up. Now this is not rusty. When they get rusty, you may have to drill them out, and that's the only option. Now let me get the one on the other side. There it is. Yep. Okay, got that. Second one is out. Now, over here, that was underneath that bolt, is the ground wire. So the white wire is ground. The yellow LR wire is positive. That goes to the solenoid to power it. Let me take this. Where'd my tool go? I'm always losing the tool down here. Okay, I take the LR wire off. All right. And then, oops. And we're going to discard that. That's potentially a working solenoid, but I don't put used ones back in. And I'm going to unravel the yellow and white wires that we're going to use here. There we go. Now, if this was an older model, pre-22, what you would see is two wires coming off of this white ground terminal. One that just disappears up into the cable one. That's actually the ground wire. The other white wire isn't really ground. I mean, it's connected to ground, but it's going over to a diode that's connected then to LR. So these two wires in earlier models are connected. We're going to simulate that by adding our own diode. The diode that's there is in the correct orientation. You leave it attached to the LR side. You simply cut it halfway in the long cable one between here and the white terminal, and you get rid of the excess wire you don't need, and then put a blue-colored ring terminal on the end of that wire, the white wire, and then that goes on the SIG connection. We're instead going to preload our diode. Now, what did I do with the diode? I showed it to you, and now I lost track of it. Oh, here it is. Okay, so we're going to put our diode, we're going to preload it onto the IGN, which is the LR wire, and the SIG, which would be the other side of the diode. Now, the important part of this is that we want positive 12 volts to trigger this to say, you have the ignition signal, the engine's running, go ahead and operate normally to allow the batteries to charge. When what we don't want to do is let that 12 volts come over to the SIG wire, because then it'll just close immediately when you run the engine. And that's not what you want. You want the 12 volts to be blocked so that only when you connect this to ground, which we'll do at the switch later, it will trigger the SIG. This will be triggered by 12 volts or ground. And I don't know if you can see this, but there is a ring on one side of the diode. And that indicates the polarity of it. It's kind of faint. But you can see there on the lower end from your perspective, on that diode is a ring all the way around it. That is equivalent in a schematic to the bar symbol. So there's a triangle pointing to the left, pointing towards this terminal, and there's a bar. That bar is the same as this bar around the diode. And what that bar does is it blocks the voltage. So the voltage will go one way, but not the other. And what we're going to do is take the 12 volt blocking, or the voltage blocking bar, it doesn't matter what the voltage is. We're going to block the flow of power from this signal, from this terminal to this terminal. So we're going to put the ring around, the silver ring around the one side of the diode, we're going to put that towards the left side, towards the IGN. So what I'm going to do is, actually we're going to put this SIG first. Again, you don't have to figure out which direction the diode goes if you've already got the diode attached, because that one happens to be in the right direction. And so I've got the the ring is on the side towards IG and away from the side towards SIG, so it's blocking the 12 volts from IGN or LR. Okay, so I'm going to go ahead and preload that on here, but I'm also going to put my LR signal wire on here, and we're going to tighten these down. There we go. And the other end. And these don't have to be super tight, but you want it tight enough that it's never going to come loose accidentally. That's good. All right, now I got to do the ground wire. Ground in the middle. And we get our white ground wire. And we put it on here. And I'm going to look at this and make sure that none of these are touching each other. And they aren't. Everything's tight. All right, so that's set there. Now, for mounting this, pretty much just figure out whatever orientation is going to work best. You want the chassis battery towards where the chassis battery comes in, and that's usually kind of on the short side. Sometimes you can put a little extra length. And because this is going to want to come in on the bottom side, fortunately, that's the coach battery switch. It's handy for that. Now, the trick then is, do I have some way of making this come in at just the right angle? And that's going to be the tricky part. Another good question is, do you want to mount it to the wall first, or do you want to attach the cables first? I tend to attach the cables first because that allows me to play tricks such as twisting the Li-BIM around in order to get a connection going. So, for example, I can hold it this way, get that chassis battery connection made, even if I don't tighten it down right away, and it just makes things a little bit safer with regard to that connection. Okay. And you can see how that might fit right about like that. This is going to come to there, and then it's just a question of how do I bring this last cable in, and I might be able to put it about like that. So I think that's what we'll do. So I'm going to go ahead and put some mounting screws in this, and then attach the last two cables, because I think that's going to be easy. Okay, we're back, and I've got a 5/16 hex driver with self-tapping head. Self-tapping, it's got the screwdriver bit, sheet metal screw, self-tapping. And what we're going to do is attach this in at least two places. That's one. hang the hole. There it is. That's two. All right, now this is well attached, and we can finish up connecting the cables here. Anytime I'm moving one of these, I'm holding on to it. I'm not going to let go of it because I don't want it to go somewhere and touch ground that could present a problem. All right. So we should be able to fit that underneath there. Oh, and exactly what you don't want to do. I got lucky though, and nothing happened. And then this is going to need a wrench here, or I mean pliers. We're going to bend this back. Where I can get that on there, and then a nut. Hopefully. Not sure I'm getting that to go. Now it's tight. All right, now we're going to do over here. Okay, that one's tight. I try to make sure these cables fit in the gap in the box around the top here. That may be a bit of a challenge. All right, last thing I'm going to do is I'm going to test to make sure this thing is working correctly. I'm going to do that by shorting LR to ground. LR is floating with the engine not running. If the engine was running, it would be 12 volts and I'd pop a fuse. But with the engine not running, if I short these together, I can hear it make the ka-chunk sound that it does. What it is the inside here, there's a rotary mechanism. There's there's actually a solenoid to activate it, but the solenoid doesn't directly drive the contacts. The solenoid pulls on a rotating mechanism that just then rotates in the one direction. And every time it makes that ka-chunk sound, it's switching it on or off. What I did there was simulate pushing the coach battery switch by grounding LR and say, hey, I want you to close now for like 20 seconds to give me a boost on the chassis engine. So we're done now in the black box. I'm going to put it back together. I'm going to tuck this thing, which does not exist in the pre-22 years, so don't worry about that. I'm going to tuck this around somewhere to keep it out of the way. There we go. That's all I have to do. And then we put the box back on. Making sure that things fit. Yeah, all right. Oh, I need the drill driver. There we go. And I got one more on here. And one on each side. Last screw. There it is. Nope, I didn't get it. Why did I get it? Oh, slide down. That's why. There we go. All right. Box is in. We've proven that it will make its noise when we ground LR. So we'll clean up and move on to the boost switch, where there's a small change there to do the ground signal. All right, and being as this is one of the new chassis, we have the plate with the boost switch on it, the metal plate, instead of the boost switch mounted to the bit of plastic directly. So we're going to take the 4 screws out. This is actually a little easier to do because you don't have to take all of this off to get to the back side of the switch to make the change. All right, we take the switch out, and then we run into, commonly one of the difficulties is the cable is too short. So what we're going to have to do to do the work on it. So what we're going to do is squeeze the sides here and release the switch, and then pull the cable down by the brake pedal and up to be worked on. The center in this group of 3 here. So there's 1, 2, 3, and a separate 4th one along one side. The center of the 3, JF. Probably can't see it, but it says JF right there on the cable. D-JF18 is what this particular one is labeled. There we go. All right. Now I can show you what we're doing. So there you can see JF wire. JF is one of the JA through JG 12 volt off the fuse box. So you're asking yourself, why is there 12 volts from the fuse box coming up to the boost switch? This is house power, not chassis power. This is actually house power installed by Winnebago. And the reason is that if your chassis battery was so dead, even to the point that the battery wasn't even connected, I mean, somebody had taken the battery out, you could still push the switch because you got house power here, assuming your house power is on. You can still push the boost switch and send the house power down to the relay to close the relay to make the chassis system be able to be jump-started literally by the house batteries. So the JF wire, what we're going to do is we're going to cut this here. And we're going to take the end that is going up to the switch, and we're going to instead connect it to the white ground wire. And we're going to do that with one of, where did it go? Here it is. We're going to do that with one of these. Not the absolute best. This is an IDC connection, insulation displacement connection. Not absolutely the best tool for the job, but in this particular instance, it's reliable enough, and it's streamlined with the wires. So what I'm doing is I found the one end has got a block on it, so I'm pushing the yellow wire through the center point to hit that block, and then I'm going to slip the white wire in front of it. Then I'm just going to clamp that down to make that connection happen. And be careful not to let that short because I'm touching the ground here. And close that up. All right. And there, it snapped. Okay. And then I'm going to take my black electrical tape, and I'm going to start by covering up this JF wire. Now, an interesting side note to this is that because JF is power from the 12-volt fuse box, if ever you had an appliance, something 12 volts rather, some 12-volt device that you wanted to have powered up here in the dash area, but run it from the house batteries, here's your wire, JF, and the white is ground. If you splice onto these two wires, you got 12 volts from the house battery. Anytime the coach battery switch isn't in the off position, anytime the power's on in the back, then you got power here too. So you could run something like a CD radio or something, or another 12-volt outlet charger phone from the front, even when the engine was off, kind of thing. All right, now that we've finished that, I can fish this back up to the hole where it needs to be, and then we'll put that switch back in place. Okay, so we got our connector. We got our connector. We line up the pins on the switch. Put that back together. Yep. And now if I test this, I can hear that sound of it closing again. Put the screws back in, and that's all done. Now, it's important to know, there's that sound of it opening again. It's very important to know that you're not going to hear this thing switching in and out usually while the car engine is running. So you're not worrying about that. But during the day when the solar is charging the lithium batteries, if the lithium batteries get charged up enough and the chassis battery here is drained enough, it can automatically switch in order to try to charge the chassis battery. That's an automatic function. The other thing that can happen is that late at night, while you've got if you're plugged into shore power, that charging can again enable the charging of the chassis battery if the chassis battery wears low. So you can hear that ka-chunk sound at random times anytime that you have with the Li-BIM installed. And all that means is, hey, you're never going to have to replace the chassis battery or shouldn't have to, because it should be kept charged at all times, especially if you're keeping your rig plugged in. So that's it. That is an Li-BIM installed in a 22 or later model Travato. Slight difference, the lack of needing to add your own diode, just an extra terminal on the other side of the existing diode if you are talking about a pre-22. Now, this particular install was done on a K model. The G model process is almost exactly the same, with the exception of the location of the black box. The black box on a G model is situated between the generator and the black tank, so behind the generator, between the generator and the tail of the vehicle. You actually crawl up underneath just like you were going to go work on the generator, to access for an oil change or something, to inspect the open access panel on the generator. At that point, if you look up as the drain line from the gray tank to the black, to the dump connection rather, that line snakes right underneath the black box, and you undo that connection and the other three screws, and that black box comes out. It's a whole lot harder to work on because you're jammed up against the generator, which is why I tend to do these videos on a K, because it's so much easier to have camera's view of what I'm doing. But same process, G or K, same process, 22 or pre-22, with the exception of the difference in the isolation solenoid. You're going to see visually a different unit, although they work the same. And then the lack of the diode on the 22, that you have to add your own diode, which is just any 1N XXX diode will work just fine. We're not talking about any significant power or anything. There's no requirements on this diode other than to be a diode. And that's it.
So LABIM installed. That means you will not have to replace the isolation solenoid. You've already done it for the last time, because they all will fail eventually. I don't care how expensive, fancy Cole Hersey or whatever you get, the isolation solenoid will eventually build up carbon on the contacts and die. Now, only the rotary type mechanisms wipe the contacts every time they rotate, and thus keep the contacts clean enough to keep it from failing. Done. See you next time.